Audio Jungle. Audio Jungle.
What are you doing?
Who are you?
I am the tree. Again, what are you doing?
I'm destroying you.
For that bad behavior, I will punish you. The punishment is that you will be sick, and the only way that you will get healed is by solving antiderivatives.
This is antiderivatives, but the problems given to me is beyond my understanding. How can I answer this? If I can't answer this, I will sick forever.
Tada! I am Magic Hexagon, and I will teach you, and I will help you. Tada!
Aha! Magic Hexagon!
So, I'll be teaching today about the quotient identities. So, to know the quotient identities, we should learn first to use the magic hexagon for trigonometric functions. So, this is the magic hexagon. So, if we have tan here, the answer is equal to sin x over cos x. It can be also secant x or over cosecant x. So how did I derive with that answer? So by using the magic hexagon, I use a pattern. So I'm looking for tan. So the pattern is like this. Tan is equal to sin over cos. So, from point A to point B to point C. So, point A is the quotient, point B is the numerator, and point C is the denominator. Tan is point A, point B secant, point C cosecant. Point A, quotient, point B is numerator, point C, denominator. So, we have sin x here. So, we're doing product identities. So, in product identities, sin x will be equivalent to tan x times cos x. So how I come up with that? So the pattern is tan going to sin and cos going to sin. So as you can see, the middle trigonometric function is the answer from point A to point B to point C. So we have point A and point C, and the point B is the product.
This is reciprocal identities. First example, sin x. The answer is 1 over cosecant x. How did I get this answer? We use our magic hexagon. This is point A, point B, and point C. The opposite of sine, the side is cosecant. So, A is the opposite of cosecant. Go to Pythagorean identities. Example number 1. Sine square x plus cos sine square x. We have our magic hexagon, and there is a pattern. Sine going to cos, going to 1, tangent going to 1 and going to secant, 1 going to cotangent and going to cosecant, and there's sine plus cosine square equal to 1. So the answer is 1. Example number 2, cosecant square x minus 1. Now the answer is unknown. We will look at equation number 2. 1 plus cotangent square x equals cosecant square x. And the factor is in there. We will subtracting by 1 in both sides. So, cosecant square x minus 1 equals cotangent square x. So, the answer is cotangent square x.
So there you go. So for finding the antiderivative of this, so we will refer to our magic hexagon. So cot of x over cos x, refer to the magic hexagon. So cot, where is cot? Cot and cos. So it is equal to cosecant. Times cosecant squared x minus 1, Pythagorean identities, that's equivalent to number 2, cot squared x. So I got that by altering this equation, this one. So I move the negative 1 here, so it is cot squared x over product identities, cosecant times cosine. Cosine times cosecant is cotangent over cot x. So we have cosecant x times cot x. So we have cosecant x times cot x. So cosecant and cotangent products identities cannot be applied. So let's check our antiderivative, and we can see that in the number 6 we have cosecant x cot x dx is equal to negative cosecant x plus c. So that's now is the antiderivatives, and that's the answer.
So example number 2. Antiderivative of tangent x over secant x dx. Use the magic hexagon. This is tan and secant, then the answer is sine. Antiderivative of sine in x dx in quotient identities. Then we use the antiderivatives table. The antiderivative of sine x dx is negative cosine x plus c. So this is the answer. Example number 3. Antiderivative of cotangent square x dx. We use the Pythagorean identities. Cotangent square x is antiderivative of cosecant square x minus 1. Then the antiderivative of cosecant square x is negative cotangent x. Then the antiderivative of 1 is negative x plus c. So this is the answer.
So we have set x, tan x, cosecant x dx. So we're looking for its antiderivatives. So let's refer to our magic hexagon and see. Sec times tan, using product identities, sec times tan, that's not possible. And sec times cosecant, that is not also possible. So we'll try tan x and cosecant x. So tan x times cosecant x is equal to sec x. So antiderivative of sec x times sec x dx. So it is equal to sec squared x. And the antiderivative, by referring to the antiderivative table, sec squared x is equal to tan x plus c. So that is the answer.
Now, I have solved all the problems. Thanks to Magic Hexagon, the curse given to me by the tree is now removed.
You're welcome, but promise me, don't hurt the tree or the environment anymore.
I promise. Thanks to you, Magic Hexagon, for teaching me the antiderivative of the problems.